Have you ever looked up at the stars and wondered, just how far away is the edge of the universe? What if I told you that the most distant galaxy we've ever seen might change everything we thought we knew? And what if it even hinted that our entire universe exists inside a black hole? Stick with me, because this gets wild. For years, the champion of distant galaxies was GNZ11, discovered by the legendary Hubble Space Telescope. It was a monumental achievement. Hubble, with its 2.4-meter mirror, peered deep into the cosmos, but even it had its limits. Then, everything changed. Enter the James Webb Space Telescope. With its enormous 6.5-meter mirror, it's designed to see an infrared light, the stretched ancient light from the universe's dawn. Webb didn't just pick up where Hubble left off, it shattered the records. In one of its early missions, Webb spotted a galaxy named JADA's GS Z14-0. It officially became the most distant confirmed galaxy ever found, with a redshift of 1432. Now, redshift is how we measure cosmic distance. The higher the number, the more the light has stretched as the universe expanded, meaning the farther back in time we're looking. But just when we thought we'd reached the limit, another discovery surfaced. A galaxy called MOM Z14, with an even higher redshift of 1444. We were now looking deeper into cosmic history than ever before. What was truly shocking, though, wasn't just its distance, it was how it looked. MOM Z14 is tiny. It's only about 500 light-years across. For comparison, our Milky Way is a sprawling 100,000 light-years wide. Yet this little galaxy shines with an incredible brightness, bursting with newborn stars. It's a cosmic nursery from the earliest chapters of the universe. But there was a catch. Something was missing. Usually, galaxies that form stars this fast have a supermassive black hole at their center. This one didn't. When astronomers pointed Webb's spectrograph at MOM Z14 to analyze its light, they found something even stranger. The galaxy was unusually rich in nitrogen. This chemical signature is similar to what we see in the oldest star clusters in our own Milky Way, which suggests that stars in MOM Z14 are forming in extremely dense environments. This was a huge surprise. According to our models, galaxies this early in the universe should be chemically simple, made up almost entirely of hydrogen and helium. But the nitrogen in MOM Z14 tells a different story. It suggests multiple generations of stars had already lived and died, seeding the galaxy with heavier elements long before we thought possible. This discovery implies that galaxy evolution might have started much earlier than we ever imagined, and it raises a mind-bending question. How many more galaxies like this are out there? Before Webb, astronomers thought these ancient galaxies would be incredibly rare, but now they're showing up everywhere. These bright, early galaxies, often called little red dots, are appearing all over Webb's deep field images. MOM Z14 may hold the record for now, but it probably won't for long. The more we look, the more we find, and every new discovery is rewriting our understanding of the universe. MOM Z14 seriously challenges our models of galaxy formation. Our theories predicted that the first galaxies would be small, faint, and chemically simple. But MOM Z14 is fast, bright, and complex. It's not that our models are totally wrong, it's that they're incomplete. This little galaxy could be a clue that the early universe was far more active and dynamic than we ever gave it credit for. And the story doesn't end here. Later this decade, a new telescope, the Nancy Grace Roman Space Telescope, will join Webb in its quest. Roman will scan much larger areas of the sky with incredible detail, potentially uncovering hundreds. But now, let's get to the even stranger part. While analyzing data from Webb, some scientists have proposed a theory so bold it sounds like science fiction, that our universe itself might exist inside a black hole. Think about this for a second. Recent studies have found that the majority of galaxies seem to rotate in the same direction. In a perfectly random universe, you'd expect a 50-50 split, but that's not what we're seeing. This bizarre pattern challenges our core understanding of cosmology and hints that something much deeper is at play. According to a theory known as black hole cosmology, our entire observable universe might just be the interior of a black hole that formed in a larger, parent universe. The Big Bang, as standard theory goes, started from a singularity, an infinitely dense point. What else do we know that has a singularity at its center? A black hole. If this theory holds, the Big Bang wasn't an explosion in empty space. It was the birth of a new universe, nested inside an old one. This would mean that every single black hole in our own universe could be a gateway, a seed for another baby universe. It's a cosmic family tree of unimaginable scale. This idea also offers a potential explanation for why the laws of physics seem so perfectly fine-tuned for life. Perhaps only black holes that give rise to stable universes like ours can survive and replicate through this cosmic cycle. In some versions of this theory, a property of space-time called torsion prevents singularities from collapsing forever. Instead, it causes a big bounce. That rebound could be what we perceive as the Big Bang, the rebirth of space and time from within a black hole S-core. If that's true, the cycle of universes could be eternal, with each black hole birthing another over and over again. Some studies even suggest our universe has a preferred axis or direction, meaning it's not perfectly uniform. This cosmic alignment directly challenges the long-held principle that the universe looks the same in all directions. In the end, from the tiny, distant galaxy, MOM Z14, to the grand, mind-bending theory of a universe inside a black hole, we reminded of one simple truth. The cosmos is far stranger and more mysterious than we ever imagined. Maybe our entire understanding of cosmic origins needs a reboot. And maybe, just maybe, we are living inside something so much bigger than we can ever comprehend. Thanks for joining me on this journey through space and time. If you enjoyed this, don't forget to like, subscribe, and hit that notification bell so you don't miss our next dive into the mysteries of the universe. See you next time.